Welcome to the third lecture of Parallelogram Method. Today we will be solving a similar kind of problem of a cable attached to a hook, but this hook is vertically attached to a wall, and we have two cables. The first one is of F1, which is of 250 Newton, and the second one is of 375 Newton. The first one is making 30-degree angle from the Y plane, and the second one is making 45-degree angle from the X plane. So what I am going to do is first place back this line over here, and remove this so as to save my time. So firstly, I am going to work on the internal angle. We know that the total angle in a quarter is of 90 degree. So if this is 30 degree, the remaining will be 60 degree. How we can do that? 90 minus 30 would be equal to 60 degree. So if this is 60 degree and this is 45 degree, the internal angle, complete internal angle will be of 60 plus 45 equal to 105 degree. I am writing it over here. I am using another marker. Let me point it out. 105 degree. Now we need to trace parallel lines. So you guys will be using scale, but I am going to use my intuition and try to trace it. Hopefully I can do that. Okay, so this line goes in this way. And this line come parallel over here. Hopefully I made a good parallelogram. No, I couldn't. No, I couldn't do that. So you guys should be using scale. There. Now it's better. So what I am going to say that if this line is of F1 and it is of 250 Newton, the parallel line will also be F1 and it will be of 250 Newton. Similarly, this is F2, so this will be also F2 is equal to 375 Newton magnitude. So the resultant force should lie over here, and we are going to call it as Fr. I am going to say it as a resultant force. So if this angle is of 105 degree, this angle will also be of 105 degree. So if I want to find these two angles, what I need to do is I need to subtract these both angles from 360 degree, because 360 is the total parallelogram angle. 105 divided by 2, so this will be 360 minus 10 divided by 2, it will be 150 divided by 2, so this will be 75 degree. So if this one is 75 degree, let me write it down. So this side will also be of 75 degree. So now I am going to take this triangle and use it to solve the rest of the problem. This is a rough sketch just to show you guys. So this will be F2, this will be F1, this will be Fr. So F2 we know that it is of 375 Newton, this one is of 250 Newton, and Fr we don't know. If we call this as A, this as B, and this as C. So what will happen? The opposite angle, this opposite angle will be alpha, this opposite angle will be beta, and this opposite angle will be gamma. And we know the gamma value. The gamma is 75 degree. So what we need to do, we need to apply the cosine law. So applying cosine law. So what does it say? It says that C is equal to A square plus B square minus 2AB and cosine gamma. We have already covered it. So for us C is FR, FA is F1 and B is F2. So we will update the equation accordingly. Now we are going to put the values. So F1 is of 250 square, F2 is of 375 square minus 2 into 250, 375, and cosine gamma, we know that the gamma value is of 75 degree. So the FR will be equal to 393.192 Newton, which we can say is equivalent to 393 Newton. Now we need to find this alpha value over here, because this alpha will lead us to the pi value. So we have this over here, alpha, and what we need the counterclockwise angle from the x-axis over here. So let's first solve the alpha, then we will get to it. So now we need to apply sine law. Sorry for the noises, there is construction going upward on the upper floor. I can speak properly. I can't speak properly. Okay. So A upon sine alpha is equal to B upon sine beta, which is equal to C upon sine gamma. So in our sense, it is F1 upon sine alpha, which is equal to F2 upon sine beta and Fr upon sine gamma. I have these values, F1 value, Fr value, sine gamma value. I need this one. So what I am going to do, I am going to take this side. So I am going to say that F1 upon sine alpha is equal to Fr upon sine gamma, and I am going to solve it for alpha. So what will happen? Fr will come over this side and sine alpha will go over there. So F1 upon Fr, and the sine alpha is on this side. Sine gamma here is in division, so when it will come to this side, it will be multiplication. So what I am going to do, I am going to say that when this sine goes over that side, it will become sine inverse. So F1 upon Fr multiplied by sine gamma, and when we will solve this bracket, we will take the inverse. So now we are going to put the values. We know that F1 is of 250 Newton, Fr is of 393.192. I am going to put the whole value over here, and sine gamma, we have the gamma value which is of 75 degree. So the sine inverse, when we will solve this, we will have sine inverse of 0.6142. 0.6142. And when we will take the sine inverse, the alpha will be equal to 37.79. 37.79 degrees, which we can say is equivalent to 37.8 degrees. Now we have the alpha value. What we need to take the counterclockwise distance from the x-axis. How to find it out? How to find it out? We have first method like just a minute. The alpha is distance, the distance between FR and F2. But we don't have this portion over here. We do not have this portion. So what we are going to say, that if we want to take a distance from here, first we need the complete distance from here to here. So how can we take it out? We can say that if we take out 45 degree minus the alpha value, then we will have this distance. If we have this distance, then what we can do? We can utilize it to solve the counterclockwise direction problem. So what I am going to say that that pi which will be clockwise. See, this distance will be clockwise because it is moving in the clockwise direction. Would be equal to 45 minus alpha. So 45 minus 37.79. I can say that 37.79. The pi clockwise would be equal to 7.20, 7.208, which I can say is 7.2 degree. Since now I have this value 7.2 degree, I can take out this value. We know that the whole quadrant, if we start moving from 0 and end up at here, we will move 360 degrees. So what I am going to do, I am going to take this value out from 360, then I will have this angle, the counterclockwise distance from the x-axis. So the pi counterclockwise would be equal to 360 degree minus 7.2 degree. So what will be the answer? The answer is, I am writing the exact one, 352.78 degree, and we have solved the problem. Thank you.